Welcome to another great show right here on ITProTV. You're watching the CompTIA IT Fundamentals for exam FC0-U61, if I remember all that correctly. And what we're going to dive in today is going to be computer operating systems. And here to help us to get a better understanding on that topic is going to be Mr. Don Pezet himself. Don, welcome to the show.
Hey, thanks for having me, Ronnie. And I'm excited to jump into this because in this episode, we're going to be talking about computer operating systems, which are an incredibly important part of the user experience with computers. You know, when you interact with a laptop or a desktop, you are constantly interacting with an operating system. And most people don't even think about it anymore. We think of the applications that we run, web browsers and spreadsheets and so on. And we don't necessarily realize that in the background, there's this operating system that is responsible for darn near everything that occurs on the computer, is handling the total interaction between you and the hardware that you're using. So a pivotal piece of how a computer functions. And as part of an IT fundamental certification, it makes sense that we need to understand how the heart and soul of our computers work. So in this episode, we're going to take a look at what makes up an operating system, how they function and do what they do, and take a look at a couple of the different operating systems that are out there in the real world to give you an idea of some of the options that are available.
Now, Don, when you talk about this idea of user interaction with the computer, I just go to my computer and I have something like Cortana on it or Siri, and I just say it and it works, Don. So what do you mean that it doesn't do what I want it to do?
I know most of us grew up watching like Star Trek, right? And you never saw Captain Kirk break out a keyboard, did you? He just talked to the computer and say, put it on screen or whatever, and it happened. Well, it sure would be nice if we could interact with computers with straight language, and that's coming, right? We have Siri and Cortana and things that are getting closer. They're still pretty crummy, though. So most of us, though, are interacting with a computer in our native language, right? In English, and I might not be able to say it. I might have to type it, but I am doing something in English, right? So for example, let's say that I want to browse to a website, right? I've got a little old diagram for this. So I want to use a computer, and I want to pull up a website. I want to pull up www.google.com. Well, in my mind, what I'm thinking is google.com. But that's not what the computer is thinking. What the computer is thinking is, well, it's thinking in binary, right? It's an electronic device. It's using electronic impulses. It's communicating in ones and zeros. That is very, very different than what we communicate in as human beings. So how do I tell the computer I want to go to google.com when the computer doesn't even understand what that is? Well, the operating system is what's sitting in between me and the computer. And it's listening. It's listening to the keyboard, to the mouse, to microphone, whatever it is that I'm using to communicate with the system. And it's receiving that information, translating it into a way that the computer can then understand. Now, the operating system is rarely working by itself. It's normally got other applications that go along with it. So, for example, if I'm browsing the internet, I need a web browser. And maybe I have Google Chrome or Internet Explorer or Mozilla Firefox. Well, how do those programs know to talk to my hardware? Usually they don't. Those programs know how to talk to my operating system, and they leave it up to the operating system to talk to the hardware. When you buy a new computer, like a laptop, a desktop, a server, the only software that you normally get is the operating system. And then we start adding applications on top of it to make it do more, to make it do all the individual tasks that we want. But that operating system, that is the core common component that every computer needs to have in order to function, in order to operate. That's where that name, operating system, comes from. Now, operating systems have evolved a ton over the years. Back in the 1970s, when a lot of this stuff was really developing, operating systems all looked the same. They were command line interfaces. You pushed power on the computer and you were greeted with a little prompt, and you could then type commands in, right? Not very user-friendly. It was designed for more sophisticated users. And that experience really kind of held computers back. And then in the early 80s, and really throughout the 1980s, we saw operating systems take a different spin. Now they became graphical. A graphical user interface became very, very common. And so you end up with modern operating systems today that, when you look at them, look something like this, right? This is Microsoft Windows 10, which is the most popular operating system on the planet. So this one's run by most people. Odds are you at home are running this one. It's not the only operating system that's out there, right? There's plenty of others. For example, I'm on a laptop, and my laptop is running Mac OS. That's a different operating system, and it looks like this, right? Again, another graphical user interface that I can interact with. But there's other operating systems still, things like GNU Linux. Linux is actually a very old operating system, older than than well, hang on. Linux itself actually isn't that old. We'll talk more about it in the Linux show. But Linux is built with compatibility around another operating system called Unix, and Unix is older than the other operating systems that I mentioned. And Linux looks like this. It's very, very similar, right? So this is actually Ubuntu Linux. And when I go into these operating systems, what I'm really seeing is a way for me to interact with the computer. I want to browse the internet. How do I do that? Well, in Linux, I've got an icon for my web browser right here. I click on the icon, and here comes my web browser, and I can get out there and I can browse the internet. Apparently slowly, but I can do it. There we go. And so now I'm in my web browser, and I can go to www. We'll just go to Google, and there's Google's webpage. Back in Mac OS, I say, all right, I want to browse the internet. Well, right down here, I've got an icon for Safari. I fire that up, and now it's going to launch Safari, and I can type in www.google. Actually, they had a shortcut right there on the screen. I could have clicked, right? Little variations, but by and large, they're functioning the same way. And lastly, right here on Microsoft Windows, same thing, right? I've got an icon for the Microsoft Edge browser right there on my desktop. I can fire that up, and I can browse to Google. These are three very different operating systems, but they're all giving me the same ability. They're giving me the ability to launch an application that I can then use for personal or business use or whatever, but to get a job done, to achieve a task, right? Remember, the computers, when they were originally designed, were designed as tools to perform some kind of work function. Now, today's computer is very different, right? You've got video gaming rigs where people are doing all sorts of crazy things. And it's not so much about work anymore. So we've seen computers start to divide up, and now you have not just one generic type of computer. If it was that way, we'd still have computers that were the size of houses. But computers are much more purpose-built, and operating systems can be much more purpose-built. So, for example, when I'm on a desktop, I expect a nice graphical user interface where everything's easy to use. But if I'm on a server, for example, a server is a very different beast altogether. It is built entirely for performance. We're not going to have graphics like this. We're not going to have fancy animations and things. It's going to be much more streamlined to get the most performance possible. Operating systems like that are very, very different. Now, each of these operating systems have evolved a ton over the years from what they originally were, right? Many of them, like Linux especially, right? This one, when I look at this Linux desktop, this is easy to use. It's a graphical user interface. The icons for most of what I want are right here, and if they aren't, I can expand out the app drawer, and now I'll see additional applications, or I can install applications and so on. What I've got is there. But in the initial versions of Linux that came out, and the versions of Unix that came before it, that Linux is an extension of, those didn't look like this. In fact, what they looked like was this, a black screen with some text on it. And you could get in there and you could type commands. If you knew the commands, you could type them. If I said, all right, I want to see what files are in this directory, so you could type the ls command and pull up a directory and see these files and folders. And if I wanted to change into a directory, I would do cd and I would type whatever directory it was that I wanted to get into, and I could pull up that listing. In the olden days, when you push power on your computer, this is the experience you got. It took you to a black screen, and you could then type on it. In fact, monitors back then were usually monochrome monitors. They were either green and black or amber and black. They didn't even deal with color monitors. So why bother with color? It's just text, right? But today, it's so much more, and it shows how operating systems have changed. Now, we still do have a lot of variations in our operating systems, though. In a desktop, I expect to have a ton of applications like this, right? Like a word processor, a web browser, and in Mac OS, you have the same thing. You have a word processor, you have an email client, maps, things like that. In Windows, same thing again. There's a lot of applications here that are already installed for me that are designed to make an end user happy, to achieve my needs, right? But there's also specialized operating systems, really specialized operating systems, like the ones that run inside of web cameras, right? Maybe you have a what's the really expensive webcam? Nest? No, Nest is the thermostat, right?
I think that there are Nest cameras.
Nest camera? Okay,
yeah, I think so.
So the Nest web cameras, right? Well, those Nest web cameras. Let me just do a quick. Oh, I did a Bing search that might turn something up. So anyhow, the Nest web cameras. Those web cameras, they're a computer. they're a computer and they've got a camera on them that takes a picture, but it's not something that's designed for a human to interact with directly. I can't plug a keyboard and mouse into this, right? I can't hook a monitor up to it and see what's on it. Instead, it's running a very specialized operating system, right? That actually functions more like a server. A server is designed for you to interact with it and many people to interact with it all remotely, not actually sitting at the machine itself. When I go to google.com, their webpage is being given to me by a server, a computer that's running a server operating system that's specifically designed to hand out that web page, versus a workstation operating system, what we would use, which isn't designed for one specific task. It's designed to do whatever we want it to, right? Multifaceted. Well, by specializing in a single task, this web camera can do it much faster, much more efficiently, and with less hardware, which means it's a reduced cost. A laptop might cost me $800, but this webcam costs $200. They both have RAM, they both have processors, they both have storage, they both have an operating system, but this one is designed to do just one task, and that brings that cost down significantly. Now, when an operating system is stuck on hardware like this that we can't directly use, that's called embedded firmware. Embedded firmware is an operating system that's built right into the circuit board of this camera. I can't replace it. I can't say, oh, I hate that operating system, I'm going to change it out for something else. It's built into the hardware of that camera. Versus my laptop, where maybe I look at it one day and I say, you know what? I am sick and tired of Mac OS. I don't want to run it on here anymore. I could format my laptop and put Linux on it, or Windows for that matter, or whatever. In fact, what you see me doing here, I'm running 3 different operating systems on my laptop, not just one, so that I can move between them, well, here for the show and demonstrate this. So that capability, that's an important thing. And now it's getting even more advanced, where you can do what's called a hypervisor. Hypervisor is a really fancy type of operating system that lets you run more than one operating system on top of a single piece of hardware, which is what I'm doing here. So my laptop is actually running Mac OS. That's the operating system that's running on here. But I've got Ubuntu Linux and I've got Microsoft Windows, and they're all running in this virtualized space, this virtual memory. And or not just memory, CPU, storage, everything's virtual, to be able to run these different operating systems. Those are different ways that people can run these, and it's really a rapidly changing industry. Things are advancing so quickly as operating systems evolve and that functionality expands, and we see more and more user demand. Users are expecting their operating systems to do more today than they ever did before.
Now, Don, I have another question here, since you started mentioning the idea of like the embedded as well. What about things like mobile phones and smartphones? Do those have operating systems, or are they the embedded type where we're not really interacting with them?
So they absolutely have operating
Okay.
systems, and they count as being embedded, but it really is kind of blurring the line. Like, modern cell phones are very, very close to regular computers. They have on-screen keyboards, humans interact with them, they have screens, and in fact, the Linux operating system that I brought up more than once here, this Linux desktop, right? If you have a Google Android phone, the kernel, the key piece of your operating system on your Android phone is the same as the one for this Linux desktop right here. So Android phones are effectively running Linux. Now, they're customized pretty heavily to run on that phone and support wireless networks and all that other stuff, but it is the same heart. Deep down under the hood, it's the same heart on an Android phone and the Linux operating system. Now, if you have an iPhone, that's not the same. Like here, this is Mac OS. Mac OS is very different from the iOS that runs on an Apple iPhone or iPad. But those are operating systems as well, right? They're performing the key functions of what an operating system does, right? And what is that key function? Well, it's how we allow a human to talk to the hardware and get the hardware to do things, to do what it is we need it to do, right? Let me bring up, I have another diagram somewhere. Let me bring this up here. All right. When we buy a computer, what are we buying? We're buying a collection of hardware, right? It might be CPU, right? That's your processor. The processor, a lot of people refer to, like, if you have a desktop computer and you have a tower, a lot of people call that tower the CPU. Well, there's actually a lot of stuff inside of that tower. The CPU is just one little chip inside of it. or in my laptop, there's one little chip inside of it that is the CPU, the central processing unit. But people refer to the entire computer as the CPU because the CPU is so important, right? It's like your brain, the human brain. Brain's really important. You can't function without your brain. But I don't refer to my entire body as my brain, right? It's just, this organ stuck in your skull. Well, that CPU in your computer is the same way. It's doing the thinking, right? But thinking by itself isn't enough. It needs other pieces. It needs things like network interface cards. How do we talk to the network? Do we have Wi-Fi? Do we have physical network, like a cable that we plug in? What do we have? We need cards that let us connect to those types of networks. What about sound? How do I play sound out so that people can hear it, right? I've got to have sound circuitry. Disk. How do we remember things? How do we store information on our computer so that it'll be there the next time that we come back? And RAM, which is very similar. In fact, we're going to talk more in detail about this hardware later on, but just as a quick analogy, disk and RAM, it's like short-term memory versus long-term memory, right? Your disk is your long-term memory. It sticks around a long time. And it's not particularly fast, but it is really good at retaining information. You have a lot of it. RAM is short-term memory. It is very fast, but you don't have much of it. So you have to use it very efficiently. So those two work together. Well, all of this hardware has to be handled. We have to communicate with it. When I double-clicked on that web browser icon and I said, I want to launch Microsoft Edge, right? And I double-click on it. I'm telling the operating system, hey, I want you to do something. I want you to launch a web browser so that I can see it. Now, in the background, what's going on is the instruction is sent to the CPU to launch the processor, to launch the web browser. It's got to go to disk to find the web browser. It's got to copy it into RAM where it actually runs from and get it up and running. And then it's got to display it on the screen. I didn't add display as an item here of hardware. The display would be another piece. So it's got to display it on the screen, and then it's got to be listening for me to interact, like mouse click and typing on the keyboard and all that. All of that is being managed by this operating system. But I don't see that, right? As the user, I don't see the processor. In fact, I didn't even see the disk or anything. It's there. I can see it if I really want to. If I, pull up let's pull up one of my property screens here, then I can come in and it'll tell me, oh yeah, I've got an Intel Core i7, I've got 4 gigs of RAM, I can find out how much disk space I have. I can see that hardware if I want to, but users don't normally think that way. They think, I just want to launch a web browser. I don't care about the hardware behind the scenes, right? So users think in terms of their software, spreadsheet, video player, web browser. That's what they think of, right? They don't think of all the hardware behind the scenes. Meanwhile, in between is our friend, the operating system. The software is running on top of the OS, and the OS is talking to the hardware for us so that we don't have to think about it. It's handling all of that. It knew where to find the web browser. It knew how to get it on screen. And it knows when I type an address, how to talk to the network card to reach out there and get a copy of that web page, and then throw it on my screen so that I can see it. So that when I go over here and I launch that web browser and I type ITPro.TV, and I type, if it'll let me, ITPro.TV, that it knows to reach out there and grab a copy of that web page and bring it up on the screen. And I didn't have to know anything about hardware. I could have just walked up to this computer for the first time ever, and I'm able to get in here and function and work. That's really what the operating systems make possible for us.
All right, now, Don, as we start talking about this, you already talked about the very fact that the operating system helps users to interact with the hardware itself. You also talked briefly about the idea of software also needing to interact with it, and the operating system is in between. But what actually allows the operating system to communicate with the hardware in the way that you're talking about?
Right. So the operating system has to know a lot, right? It has to know about the hardware underneath. And sometimes that's easy, right? So mobile phones. When you talk about like the Android operating system or the iOS operating system that's found on iPhones, well, Apple makes the iPhone, the hardware, and they make iOS, the software. So the iOS knows exactly what hardware it's going to find, right? It knows what's there. It's easy, right? But there's other operating systems like Microsoft Windows, where you can go buy a copy of Windows by itself, and then you can load it onto a computer, and it has no idea what hardware it's going to have. So it has to be ready. It has to kind of detect and learn that hardware and figure it out, right? And to do that, it's dealing with something called a hardware abstraction layer, or HAL. And a hardware abstraction layer is basically where the operating system says, look, I don't want the software to even think about hardware. Don't even think about it. The software just needs to know how to talk to the operating system. And that's it. And then the operating system will figure out how to talk to the hardware. And the operating system vendors, they work with the hardware vendors to figure out what hardware is out there that they can support. The hardware vendors will create software that's called a driver. And a driver is what lets the operating system talk to the hardware. It tells it how. It says, hey, I've got this really fancy printer, and it's got color ink cartridges in it. It's got 4 paper drawers so you can pick from different types of paper. Well, how does the operating system know that? It doesn't, right? But the driver software that printer manufacturer creates tells the operating system. And once the operating system knows that, any software will be able to use it because the software just needs to know how to talk to the operating system. The operating system is in the middle of every communication that's happening. It's sitting right there in between that software and that hardware. And there's actually 2 big advantages to this. One, it makes software development way easier, right? In the olden days, right? If we were filming this video in 1987, right, or 1988, and in fact, some of you might remember, like back in the old WordPerfect days, that if I ran WordPerfect and I wanted to be able to print to my printer, I had to get a driver for WordPerfect, for that software, so that it could print to the printer. And then if I closed WordPerfect and I opened up another program, it wasn't able to print. I would have to get a driver for that program. Every software had to have drivers for the hardware. It was a nightmare, right? And so only a couple of software applications were really widely supported, and it really just didn't create a very diverse environment for software. It's not like that anymore. Now, there's 3 main operating systems out there. There's Windows, Mac OS, and Linux. Windows has about an 80% share in the market. So most people run Microsoft Windows. Mac OS is about 5%. You have mobile platforms that are covering another large percentage. And then you have Linux that's floating in the like 1 or 2% range of market share. So those are really it. Those are the 3 big ones. And I say big ones, like Linux is actually a very, very small one in that market. In the server world, it's very different, right? Linux has over 40% of the server market share. It's very different depending on what you're doing. But if I'm a vendor, I'm making a printer or a video card or a headset for listening, I don't need to create drivers for every program that's out there. There's millions of programs. I'd never get it done. I just need to create drivers for those 3 operating systems. If I create a driver for Windows, really if I just create it for Windows, I'll have millions and millions of customers. If I can do Windows and Mac OS, that helps too, right? Not a ton. Mac OS is a pretty small market share, but it still adds on. Linux, we don't really have an opportunity to generate revenue there, but that doesn't mean people don't make drivers. You still do see people making drivers for Linux as well. And that's all they have to do, 3 different drivers, and they're done. And when somebody writes a program, they can choose to make that program available for different operating systems, and now they don't have to worry about all the hardware under the scenes.
All right, Don, so can you give me an example of where I can find some of these different things?
Sure. So let's look at both sides, right? So let's talk about software first. I'll give you an example. I use a text editor called Sublime Text. And if I go to their website, which is sublimetext.com, you get your standard kind of marketing site. They show you, here's the product, and you can learn about it. It's great. But if I want to go and download the software, when I go to download it, I get choices. And I can see right here, I can download the one for OS 10 is the old name for Mac OS. They've renamed it. This page hasn't been updated apparently. But I can see Mac OS, Windows, and Linux. Right here, I've got 3 choices, right? 3 primary operating systems. I picked the one that I'm using. I'm running Mac OS, and so I'll download that version. Or if I'm running Windows, I'll pick the Windows version. So they're giving me the options. But the authors of Sublime Text, they just had to create 3 different versions, and that covered the primary operating systems. They don't have to worry about hardware. They don't have to worry about what video card I'm using, right? They just have to worry about the operating system. Now, on the video card side, let's say that I have a video card from NVIDIA. I need my operating system to know how to send graphics to that video card so I can see it on my monitor. Well, if I go to NVIDIA's website, I can go to their driver download page, and they give me choices as well. And I can see right here, if I pull up this is my other computer, I have a GeForce GTX 1050 card in it. And if I go to download drivers, you'll see they've got Windows, Linux, and they don't have Mac OS. Ooh, so
Nice.
they don't have an official driver for Mac OS. Now, what does that tell me? I probably can't load Mac OS on that computer. And that makes sense because Apple only uses AMD video cards, AMD Radeon cards in their Macs. So they don't allow NVIDIA cards in theirs yet. So that's why that one's left off. But I actually see some other operating systems in here like FreeBSD and Solaris. I haven't even talked about those. Those are very, very less frequently used operating systems. They're very, very specialized, really, in the compute space. So they've got extra drivers for them. But I can pick the appropriate driver, and now my operating system will know how to talk to that video card. And if my software knows how to talk to my operating system, now everybody's happy, right? My software knows how to talk to the OS, OS talks to the hardware, and everything functions like it's supposed to, right? That's what the operating system is facilitating.
All right, Don, when we start taking a look at the idea of the operating systems, are there any other additional functionalities that the operating system does? So you've showed us the basic here and the primary idea, but what other additional functionalities are we looking at?
In the early days, right? And when I say early days, I mean even further back, like the 1940s and 1950s, where computers, people were punching in cables or punching cards and feeding them into the system. Back then, an operating system simply dealt with allowing the humans to interact with the hardware and making the hardware do what it needed to do. That was it, right? But a lot of time has passed, and more functionality has gotten added to operating systems. Operating systems do so much more today, from power management to crash prevention and troubleshooting, data logging, permissions and access control. Just any number of things. Network services, acting as a server, because networks didn't even exist in the beginning, so now that's all been added to be able to act as a server. Software updates, that's a big part, right? It used to be that if you bought a computer, it was configured a certain way, and that's it. It stayed that way until the computer was dead. Now we're continually getting updates, and these are typically being fed through the operating system. These are all additional functions that your OS performs. And as we move through the IT Fundamentals series, we'll get a chance to see a number of those functions, but most of them get specialized into a particular OS. So here's something that's particular to Windows or particular to Linux. So you'll learn more about those usually in follow-up certifications like CompTIA's Linux Plus or an A+, and you'll get a little more specific there. But in a general sense, operating systems can really do anything we want them to, and it's continually changing and expanding. But that core functionality, what we described, of allowing the software to interact with the hardware and vice versa, that is always going to be a staple function of that operating system.
All right, Don, that sounds like a lot of great information on just helping us to understand computer operating systems, but there is a lot more to come. So, Don, I'm going to give you the last word on the subject. Any last words for our audience?
All right, in this episode, I tried to stay pretty general, right? Just here's what an operating system is. In the next couple of episodes, we're going to take each operating system individually and spend a little bit of time on Microsoft Windows and a little bit of time on Mac OS and a little bit of time on Linux, just to give you guys some exposure to what those operating systems are. For the IT Fundamentals exam, they don't expect you to be fluent in the operating systems, but you do need to be familiar with them. You need to understand what the basic functions are. And in real life land, when you get out there and you're working in an IT-related job, you'll find yourself being exposed to all of these operating systems on a regular basis. So it is a good idea to be familiar with them. We're going to tackle each of them in the coming episodes.
All right, Don, thank you again for helping us out, and thank you also for joining us right here. Signing off for ITProTV, I'm your host, Ronnie Wong.
And I'm Don Pezet.
Stay tuned right here for more of the CompTIA IT Fundamentals episodes coming your way.
Thank you for watching IT Pro TV.